Okay, hello everybody. Again, it's a great pleasure for me to be here. I have to tell you that, like the Dublin Jug and you all here are by far the most excited audience of all. So thank you, Barry. You make a very nice host, showman.
Oh, thank you.
You're a nice
I've been practicing this for 10 years, Yanaga, since we've been starting the Dublin Java user group.
You see, you can all reach the same level. You just have to start pressing now. Okay? And Barry seems to be a nice photographer too, even though I didn't see the pictures yet. So I can't tell for sure, but he has some style, right? Yeah. So thank you very much. That's why I'm so happy to be here in Dublin for the very first time. I had no idea how it would be. And I'm pleasantly surprised because it's a very nice city, very nice people, and a very nice jug. You're the best jug of Dublin, for sure. No doubt. And I'm a Brazilian Japanese. Currently, I'm a director of developer experience at Red Hat. My Twitter handle is @Yanaga. And today we're going to cover this subject, migrating to microservices databases. And why is that? In the past 3 or 4 years, I've been discussing microservices with different peoples and different teams. But the number one question that everybody asked me in the end was that, well, if the best practice for creating a microservice architecture is to start from a monolith and break that thing apart into different microservices, but I still have a legacy monolithic relational database, how do I deal with my data? And I didn't have an answer for that. That's why in the past 2 years I decided to do some research, and I'm talking to many different teams and people worldwide, trying to find out how they solved this problem. And I was able to collect some very nice experiences, and I was able to write them at the book. So if you have a hard copy of the book, you can read it. Everything that I'm going to present today is in a much more detailed format at the book. But if you, just in case you didn't get a hard copy of the book, the book is available online here at this URL. So if you go and type this URL, you have a link to download the book. But just if you don't want to type everything, you can go to my Twitter profile. The first pinned tweet of my profile is the link, and I think Barry put that on the webpage too to download the book, so many of you might have got that. And I'm very glad that Red Hat developers bought the royalties, so it's distributable on the website. Okay, so that's my current tip. And after I released the book, in February this year, I had many different other interesting discussions with different engineers and teams, and they were asking me questions like, well, it's not only relational database, you also have NoSQL database, you have in-memory data grids, you have other types of distributed data, not only monolithic databases. You have data streaming. These days people are talking data streaming too. And how do we solve this problem? So I've been having some discussion with different people about how can we solve or how they solve these problems. And maybe, I don't know if I'll release a new series of articles or maybe write another book about the subject, but that's something I've been researching because I was so sad that in all of the conferences and books that we have worldwide about microservices, everybody talks about the process and the code, the architecture and everything else, but nobody talks about the data. And data is usually something that survives even after your code has died like many, many years ago. So maybe the code that your application is running, the code that you have running with your application today, maybe the code is new, but it's very likely that the data on which your code is running upon has been written and recorded like 20 or 30 years ago, because systems change, but the data always remain. So that's the challenge that I had to take, because nobody was talking about that, and I was so ashamed of never having an answer. How they did it, I don't know, but I want to. So that's why I started to do this research. And many other things happened in this space later. So I was very happy because all the people that I was able to meet and talk to, it was very enriching experience to be doing the research to write this book.
Hey, are you enjoying our video? Excellent. In 2006, we set out to get all the Java community to come together to talk about the language they love. The Dublin Java user group was born. From humble beginnings with pub meetups, we now bring in Java rockstars and Java champions to Dublin every month. With the knowledge they share, these are the guys that want to help you enrich your working life. So sit back, listen in, and study those slides carefully. They are full of gems. By the end of this video, if you've learned something fabulous or have ignited just one great idea, go straight to your boss and demand a DubJug membership. Just imagine what it would be like for you to be networking and sharing great ideas with 40 other Java developers at our next event.
And I always like to start my talk with this quote, which is not mine, it's from Forbes. Not every company is a software company. I like to say you don't work for a bank, you work for a software company. You don't work for an industry, you work for a software company. Because software is changing the world that we live. Some people call this digital transformation, digital revolution. I think that digital economy is a very appropriate term for this because, and I have to explain why. I used to be one of these people that thought that economy and economics had everything to do with money. But after studying some behavioral economics and behavioral psychology, I just realized that economics is the science that studies how people interact with each other and how people into a certain system, how they change the system from one state to the other. So in economics, we're studying the motivations that people have behind making this transition. So some motivations that people have to make this transition can be love, can be hate, can be power, and can also be money. So we are studying how software is changing the world in which people interact with each other. And you also have to remember that software is made by people for people. So software development is also an economic system. We are studying how people interact with each other to produce code. Every time we forget these components, we can deliver an optimal result into production. So keep that in mind because people, in the end, I think talking to the machine is easy. Dealing with people is hard. And the funny thing is that when I decided to take a computer science degree at college, I decided to do that because I didn't want to talk to people. I was wrong because I think that by far the most important skill that I've developed in the past 7 years was the skill to try to understand people. I think I've spent like enough time of my career developing the hard skills, so I think I have a reasonable background in computer science concepts, but by far the most useful skills for me in the past years has been this empathy skills, trying to understand why people do what they do. That's why I became so interested in behavioral economics and behavioral psychology. Today, of course, I'm not an expert on that, but I've been studying this field for quite some years, and I think I'm much more tolerant, a much better person indeed, not a good one, but I'm trying to be that person. I think today, before judging people for what they do, I first try to understand which are the constraints that they have so people act the way they do. And it's very useful. I can even suggest some books for you, because it really changed my life. I hope it can change the life of somebody else too. So that's the basics of software, and some great examples of how software is changing the way that we interact with other people are that the largest car transportation company in the world owns no cars, which is Uber. The largest lodging company in the world owns no real estate, which is Airbnb. The largest online retailer in the world owns no stock, which is Alibaba. And the largest content network in the world produces no content, which is Facebook. All of these companies, they have something in common, is that they only exist because of software, and the software that they produce is changing the way that we interact with other people. So definitely, software is changing the world, and I always like to introduce myself also as a software craftsman, because I truly believe that we can change the world that we live with the software. And we can make it better, and we can make it worse too. So we can all make a decision, because we know that feeling of being miserable when we use software that's not up to our expectation. You can make a choice. You can decide if you want to provoke this sensation to people of miserability, or if you can make people delight with the result of your work. So I I think that if we're here trying to uncover better ways of delivering software into production, we are already made a decision. We want to change people's lives for the better, and of course I want you to be able to share what you're learning, what you know with other people, because it's very important for us to be able to do that. Like almost 5-6 years ago, I was in a very bad moment in my career, but I decided I need a purpose to keep doing what I was doing. I even thought about doing something else. But since I decided to be a software developer and I wanted to help people with the software I produced, I just realized that doing just my part was enough. But even though I thought that I could produce like nice code and deliver that code into production in a fast and safe way, it wasn't enough because I needed to help other people to do so. And I wanted to share maybe some things that I've learned in my career so I could help other people. That's why I'm so happy that Red Hat gives me the opportunity today to sometimes travel around the world and share some things that I might have learned in the past few years of not doing the right thing, but most of the times I learned doing the wrong thing. So I'm able to share this knowledge with you today, as I've been doing like this entire week. Yeah, and like I used to be also independent consultant before joining Red Hat. And one of the nice things that I like to say is that as a consultant, I can't tell you how to do the things correctly, but I know exactly how it doesn't work, so I can help you to prevent that, right? Okay. And since everybody is discussing DevOps and microservices today, I know it's a long discussion. I won't be able to cover all of the subjects today, but if I had to choose just one thing to say to you, why DevOps and microservices are important, I like to say that it's because DevOps and microservices, they all try to improve the feedback loop of the software development process. And if you think about that, all of the major revolutions that we had in the past 20 or 40 years, they always try to improve the feedback loop, which is an essential thing in all of the human activities that we have. Because that's how we humans improve the things that we're doing. Because what is that? We humans, we have a very limited capability of holding context into our brains. We can't hold much information, and we can't do that for a long time. So, what are we good? Which things are we good? So, we humans are good in trying to establish correlations between I'm doing this, I'm getting this result. So if I have a lot of things, doing a lot of things at the same time in my mind, if I do things, I get the result, I can't establish the correlation because what did I do that provoked this result? I can't do that. And also if I take a long time between doing something and getting the result, I can't establish this correlation. And of course the quality of my work is not as good as it could be. So the feedback loop, traditionally, we are waiting and how do we solve problems in the software world? We face a business problem that we need to solve. Quickly we formulate some hypotheses. Well, maybe I can solve this problem this or that way, but this one's going to take too much time. This one is going to be too costly. This one is on a different technology that I don't still understand. This one might work, but the only way for you to be sure that your hypothesis is going to work into production is to deliver that code into production. So we translate that hypothesis into code and we deploy. If we take a long time between thinking about the hypothesis and assessing if, well, did it work in production, we can't have an optimal output. So that's why sometimes if we take like 6 months to deliver some software in production, the business guys ask for something, we deliver 6 months, and that's why I have to admit that in my career, and I've seen many people doing that, we usually blame the business people because they ask features that nobody uses in production. Or when we face something, why the hell is he or she asking these things? These things never going to work into production, but we have the share of the fault too, because if you take like 6 months to deliver something to production, the word in which the business person thought about the problem, it changes 6 months later, or even 1 year later. So the assumptions that we had are not true anymore. So that's why usually we just face the things and we deliver to production, we don't know what happened, right? And so it's bad for the business people, it's bad for us because we're trying to solve the problems. We can't establish a correlation.
Jerry Nolan here from Stack & Co. When you want to change your job, you'll want to make a move which will give you career growth, interesting projects and a fresh challenge. At Stack & Co, we can help you make that career enriching move by taking the time to really understand your individual interest and what represents the best next step for you. Let's have a confidential conversation to discover your career enriching move. Contact me on www.stackand.co.
So we need to reduce the feedback loop, we need to reduce the time from the feedback loop so we can establish this correlation. I'm doing this, I'm achieving that into production, right? And technically, the amount of time that we take from idea to production is called the lead time. But every time somebody says, well, you need to improve the lead time of the process, it's such an abstract thing, it's such a hard thing to achieve because, oh, we know we need to be fast, right? Yeah? But how do we do that? So as a consultant, I used to tell people that the most important measure of any process that you have is, in the software world, is your batch size. And technically, the batch size is the amount of changes that you have between each one of your software releases. So when you say batch size, and technically too, the changes that you have between each one of your software releases can be in 3 different areas. You can have changes in your codes, you can have changes in your data, and you can have changes in your environment. So batch size is related to these three things. So, getting back to the feedback loop, we need to reduce the feedback loop because we want to deliver better software to production. So try to establish a very simplistic correlation with you right now. And people know that we need to deploy software fast into production. We need to reduce the lead time. So, but why don't you do that? And the number one excuse that I always received as a consultant used to be like, we can't deliver software faster into production because when we do that, we have too many bugs. We deploy too many bugs into production, so we can't be faster. We need more time to test. So if we're deploying software every month, now we need 2 months to deploy our software because then we'll have more time to test. But people don't realize that the more time you have to test, the more time you have to code to. So if you just wait, instead of 1 month, 2 months to release your software to production, you don't have less bugs. You have more bugs. Then they realize we need more time to test. Then you release it every 4 months, 6 months, every year. And I thought that like 1 year was a long enough time. It was the worst case that I've seen until this year. Because this year I visited an European country, a developing European country. And I visited this team. He was the lead architect of the team. They had 25, it was a big software company, they had 25 distributed teams. And they told me that they only release software every 4 years. Oh my God, 4 years? Do you know how the world was like 4 years ago? 4 years, but after talking to him and learning what did they do, what kind of software, it was easy to spot why they deliver software only every 4 years. Because they produce software for the local governments. And you have elections every 4 years. So they only release the software every 4 years because they deploy the software and then the next government assumes. And they might not be the ones to be hired to maintain the software, so it's not their problem. Okay? So just leaves, that's why they only deploy software every 4 years. And the amazing thing, they're going to have elections next year. And I talked to him, he said that after 3 years of work, all of the modules of the systems from the 25 distributed teams, they were already done. They just needed to integrate the modules. They told me, we still have 1 year. And he was like, I'm sure we're not going to make it. Right? Because 1 year is not enough to integrate all of these sheets. You have to make sure this sheet works together. Because everybody is guaranteeing that my module works. Okay? And we know how things happen when your module works, but doesn't work with the other modules, right? Because integration is very hard. In fact, I like to say, integration is the hardest problem for us to solve in the software development world, because we know that because when we are in small teams, things seems to work smoothly, works well. But as the team grows, things start to get slow, get complicated, because we as humans, we have a very hard time, we are very bad in trying to coordinate work between multiple people. We are very bad in that. And that's one of the problems that microservices try to solve. We are trying to split the size of the teams so we can have like different work queues instead of everybody being bounded by the same limits and everything else. But that's a discussion for another day. I even have a talk about that. But we're going to discuss today only the part of the data. So the correlation, after saying all of that, I like to say that the correlation that I want to establish is that the human way of trying to solve the bugs in production problem is try to avoid the problem, right? I don't want to suffer this thing every month. I only want to suffer that every 2 months or every 4 years, right? So, but the economical way of trying to solve this problem is the opposite one. So the human way, avoid the problem. The economical way is, how they say, feeling the pain more often. So if you're deploying software every month, maybe you need to deploy software every 2 weeks. If you're deploying software every 2 weeks, maybe you need to deploy software every week. So what's the correlation that I'll establish? What causes bugs in production? Changes. Changes in code, data, and environments. So let's try to oversimplify that. I like to say that what causes bugs in production are changes in code. So the more changes in code you have between each one of your releases, the more bugs you have into production. So the way to solve that is the less changes you have into your code between each one of your releases, the less bugs you have into production. Until if you can further even reduce the amount of things that you change in between each one of your releases. And remember, we call that batch size. So you can further reduce the batch size until they're like the ideal size of one single commit, one deployment to production. If we just decide to commit these 15 lines of code and now we have a bug into production, where is the cause of the problem? It must be on that single 15 lines of code that we just released into production. So it's easy for us to humans to establish a correlation. I did this, now I'm having this bug into production. It's much easier than like committing this code like 6 months ago and oh, now we're having a bug into production. Oh, holy shit. In which one of the 2 million lines of code is the problem? Much harder, isn't it? So 50 lines of code is much easier to establish correlation. That's why I always like to say that the batch size is the most important thing to measure in any process when you're trying to release software. Okay? And why is that? Because batch size is easy to measure. People say, oh, you need to reduce your lead time, you need to improve your cycle time and something else. Just aim for the batch size because batch size is something that we developers, we can easily measure. We know how much we're changing between each and one release. So we know if that thing is increasing or if it's being reduced. So go focus on the batch size because this is the thing that will help you to improve the quality of the software that you deliver into production. But even if you try to further reduce your batch size, like I deploy like once every month, I want to deploy every day or 2 times per day, there's something called that specific time of the year, month, week or something a day that you're allowed to deploy software production and it's established by the ops guy. Because every time you release software production, you disrupt users, right? You need to stop the servers, copy the artifacts, maybe you need to update your database schema or something else. So you disrupt your user into production. That's why you're not allowed to do that into any time of the day. But if you want to further improve your batch size, you need to break this maintenance window, which is established by the ops guy. So, but to do that, you need something that we call zero downtime deployments, which is your ability to update the system into production without disrupting the users. So this is what we call zero downtime, and to achieve zero downtime deployments, you have a single requirement. Your architecture needs to be a blue-green deployment architecture. How many of you have ever heard about blue-green deployments? Okay, not many, but I'll explain that very quickly to you. Traditional deployment architectures was like this. You have clients issue requests directly to your backend deployment, which we call the blue deployment. If you want a blue-green deployment architecture, you add another component to your architecture, which is a proxy. I'm not saying that it's a reverse proxy or a load balancer or something else. I'm just saying that it's a component that is receiving the request on behalf of the backend and is forwarding it to them. Right, so in a blue-green deployment architecture, you have two identical environments, two identical production environments, a blue environment and a green environment. Each one of them is capable of handling 100% of your requests into production to any given moment. So it's not a load balancing strategy, it's more like a failover strategy, because they both must be able to handle 100% of the requests. So how does it work? I have my request can be issued against both deployments, but if I want to release a new version of my software into production, I just ask the proxy to stop issuing requests to my green deployments. Then I stop the servers, I copy the new artifacts, I start the servers, then I issue some fake requests and wait for it to warm up. When everything is fine, update complete, but if anything went wrong, I just get as a wait. New version is not working properly, and it's safe. Because people don't realize that a blue-green deployment architecture is not the only way for you to achieve zero downtime, but also it's the safest way for you to be releasing new software in production. Because if anything went wrong, you just don't need to issue your production requests to the failing deployments. You just keep your production requests to the blue deployments. And the green, well, you need more time to debug what happened with the green deployments. So you can do that without disrupting your users into production. But if everything went well, you can just decide to repeat the process with the blue deployment. You stop the servers, copy the new artifacts, you start the servers and warm them up, and if everything went well again, you just, you can now, maybe you can use your proxy as a load balancer and issue a request to both environments. So this is how a blue-green deployment works, and this is the architecture that we use in the DevOps world. That's the discussion that we're having like 5 or 7 years ago. So that's the way that we created blue-green deployments.
I'm Catherine Askell, the founder of Guru Team. Guru Team specialises in delivering high-end ICT, technical training and consultancy services. What makes us different is that we employ the creme de la creme of specialist instructors who have vast real-world experience and passion for the technologies they teach. With a continually evolving portfolio of over 250 courses, we can customise a programme to suit your team. We have one of the largest portfolio of cloud, Linux and development courses in Ireland, and have several accreditations including the Linux Foundation, LPI and the DevOps Institute. We would be delighted to talk with you about working with your teams, so please visit our website on www.guruteamirl.com.
What I would say is that we have different time frames depending on the industry that you work with. For startups, it's very far past. For some enterprise companies, they are starting to think about implementing such architecture. What I like to say is that it took, in some cases, the very early deployments that we had, sometimes it took like weeks for us to create this kind of architecture in any deployment pipeline. But these days, 2017, you already have out-of-box tools that provide this kind of thing for you. You don't have to do that by hand, right? We need it in the past, but in 2017, it's much easier for you to consume this kind of technology because it's already out of box. And we're going to see that like after the pizza. We can see how technologies like Kubernetes, it automates all of that. In fact, it's such a simple deployment strategy that most of the modern tools, they don't even implement this. They implement like a much better deployment strategy than just pure blue-green deployments, okay? But when you're talking about the code doesn't hold state. You can just easily replace one code with the other. The code is easy. What about my data? Data is the hard part. So that's why I like to say the code is easy, the state is hard. And when I'm saying state, state can be of two different kinds. You can have ephemeral state, which is usually the state that you store in your HTTP session, which you might or might not lose. But if you lose your ephemeral state, the user needs to log back again into your application, or if he or she was filling that 200 field form, maybe he or she needs to start over again. You have some pretty mad user, but sometimes depending on your business requirements, it's acceptable. But with persistent state, it's much harder. You're not allowed to lose the state of your database every time you release a new version into production. So we need to tackle this problem of how do we manage zero downtime deployments with persistent state. So that's what I'm going to cover right now. So people always ask, okay, zero downtime deployments, but what about my relational database? My database has a database schema, and these schemas usually are incompatible because the new version of my application doesn't work with the old schema. And the old version of my application doesn't work with my new schema. So how does it work? Because you see in blue-green deployments, you have two different versions of your application running to production into any given moment. So we must solve these problems, and for us to be able to solve these problems, first step, I need to tell you that you're not allowed to change your database schema manually anymore. You need to automate everything. And the two most popular database migration automation tools in the Java world, and not only in the Java world, are Flywheel and Liquibase. These two tools just happen to be implemented in Java, but you can of course use in any kind of process. I just realized that it's very popular. It's not the only word in which I've seen that it's not that popular is for the Ruby world, because the Ruby on Rails guys, they already have their migration tools. But in many other technologies, people are using these tools to implement the database migration tools process. Okay, and yeah, they're all feature complete. It's just a matter of choice. They can both be applied whenever you start your application. They can apply the database migrations automatically because they detect in which version is your database schema. Or you can tie them to your application software deployment pipeline, which I strongly recommend. Why is that? Because in the past, usually you only had one instance of your application running to production. So it's a very good strategy to apply the migrations when your application was starting up. But now in the distributed world, you have multiple instances of your application running into production, and you don't want your migrations to be applied like multiple times. They claim they have solved this with logs in the database. I still prefer to use that as a separate step in my software deployment pipeline, but it must be a matter of taste. Okay? Flywheel base, and to explain you a technical term, migrations is the technical term that we use for the amount of SQL statements and code statements that we need to apply to change our database schema state from one point to the other. So if we want to change the database schema from one state to the other, we need to apply some migrations, which can be, usually it's SQL statements, or it can be code statements too, if it's a very complex transformation, for example. So, with these tools, we can try to apply zero-downtime migrations. The secret for zero-downtime migration is that all of our migrations must be back and forward compatible, which means it must be compatible with the previous version and the next version of your application. We also means that you need to apply that with baby steps, which means that instead of creating that huge SQL statement with 100 updates and alter tables, now you need to do that in very small steps, maybe possibly just one single statement with each one of your migrations. You also need to avoid long logs, because if you do an update statement, it takes 5 minutes to complete. It means 5 minutes of downtime of your system into production. So you need to split that. And in the database world, you use a very fancy word, which is sharding. Sharding is just a fancy word for name for splitting. So if you have a table with 1 million rows and it takes 5 minutes, maybe you need to shard your updates into 1 million at a time, so each one of them consumes like 15 seconds or something. And you need to test if 15 seconds is too much or is acceptable for you. It really depends on your business requirements, right? So you need to rehearse your database migrations up to exhaustion, not in the production database, but in a test environment, which is at least as capable as the production environment. So you can measure the time that the updates take. So in the past, if you used to have like alter table, rename column something to something else, maybe you need to split that thing and change that to like alter table, add column, update, and something, and maybe later you need to delete the column, okay? So, I've been able to collect these 4 different scenarios that teams worldwide are using to create these zero downtime migrations. I have to confess to you that most of the teams that I've talked to applying zero downtime migration were startups, but in the past year I was very happy to see some enterprise companies starting to apply these zero downtime strategies. And in the beginning, I'll describe them to you in a very quick way, but if you want that in more detail, you can read the book. In the beginning, it might look weird. Some people, when they see that, they even complain to me, it's never going to work in production. Well, I'm not saying I'm right, I'm saying that people are using this in production. But everybody that challenged these scenarios, later they reached out to me and said, well, I don't know why it works, but it works, right? So, yeah, I'm very happy that people are using it, it's working in production, even though they're not convinced that it should work properly. But everybody that tried to find a scenario that it didn't work, they created some test cases and in the end it worked. But if it doesn't work for you, please let me know, because I need to spread the word and tell other people, well, maybe there's a scenario that doesn't work. Okay? So the scenarios are add a column, rename a column, change the type format of a column, and delete a column. I didn't cover tables because if you think of a table as a collection of columns, you can easily apply these steps multiple times until you achieve what you want. So the scenarios are add a column, each one on number 1, 2, 3, and 4 are different releases of your software. So if you want to add a new column to your application, first step, you alter table add column. Second step, your code computes the read value and writes to the new column. Third step, you update the data using shards. And fourth step, your code reads and writes from the new column. And I have to tell you, between each one of these steps, you're going to open your database CLI, you're going to issue multiple select statements just to check if the data is being written properly into the database. So you can check that. And this is, people don't realize that this is the only way for you to achieve zero downtime migrations, but it's also the safest way for you to be applying migrations into production. Because with these migrations, you never issue a destructive statement against your database. All your data is still there. That's why it's so safe. Why? Because your previous version still needs the data where it was. So we never destroy anything into production. Second scenario, rename a column. So if you used to do alter table rename column, then now you need to do this at least the 6 steps, which is first step, alter table add column. Second step, your code reads from the old column and writes to both. Third step, you copy the data using small shards. Fourth step, your code reads from the new column and writes to both. Fifth step, your code reads and writes from the new column. And sixth step, you delete the old column. Not immediately, because deleting a column is a destructive statement. You just mark the column for deletion, and you create a Jira issue to your DBA saying, well, in your next maintenance window, you just perform a backup, make sure nobody is using the column anymore, and you can safely delete that. Because deleting is a destructive statement, and you never do that into the production database.
Hi there, it's Sergio Dobrovolsky here from Eventual, an IT consulting company that has a main focus on innovation. We believe that innovation is a key factor in being successful. That's why we created an innovation lab, a place where we can experiment, try new technologies, express ourselves, so in order to bring more value as possible to the company and to the community as well. If you're looking for new challenges and if you want to experiment the innovation with us, don't be shy and come and talk to us.
Right? Yeah, and I told the story before. Yeah, I did some bad mistakes into production runs, but of course I told the DBA, so he made a backup and was saying, I performed a migration, I screwed it up, and I said, well, sorry, I fucked it up, I'm rolling back. I need the data as it was before on that column. And the DBA was like, you know that I need to restore a backup. And the guy was saying, it was 8 a.m. in the morning, on a Monday morning. And the guy was like, you know that the database restore takes 10 hours to complete, right? This is going to be a very hard day. And it was like a very stressful day, I have to admit, okay? Because you had like 10,000 users unable to access the application. It was pretty tough. Okay, but I survived. And third scenario, change type and format of a column. You can see a pattern here. It's exactly the same steps. If you want to rename a column or change the type and format of a column, you need to perform exactly at least 6 steps. And not only for the scenarios, These same scenarios can be used, for example, if you want to implement a new algorithm for calculating something, but you want to make sure that it's not screwing with the database values. So what do? You keep the old algorithm right into the old column. You just create a new column, and you keep the new version of the algorithm right into the new column, so you can just keep checking if everything's okay. So this strategy is good, not only for changing type or renaming, but also if you want to implement in parallel different algorithms and you want to check the values without screwing your application, right? Because if anything else fails, you still have the old column and the old algorithm running to production. You can easily roll back. So this is also the safest approach. And last step, last scenario, delete a column. Don't. You never delete a column to production because that's a destructive statement. You've deleted a column, it's not there anymore, your previous version stopped working. So what do? You just stop using the read value but keep writing to the column because, again, your old version still needs the data that was there. But if you decide, well, maybe I really don't need that data anymore because it has been like 2 months and nobody's missing that, maybe you can stop writing the data to the column and you can mark the column for deletion so your DBA can delete the column later on the next maintenance window. That's the 4 different scenarios that people are using, and you might be thinking, why am I talking about zero downtime migrations if the subject of this talk is microservices? And it is because I just, after talking to people, they told me this is very important because in the past, the downtime of your system used to be equal to the downtime of your monolith. But now that you have a microservice architecture with multiple endpoints, you're not allowed to have downtime in your system just because one of the small microservices is updating their database. Because in that case, if you have multiple artifacts, you're just multiplying the downtime of each one of your artifacts. So the overall downtime suffers a lot. So you're not allowed to have this kind of downtime in your system just because of the database migrations, and that's why we apply zero downtime migrations. And the techniques that I'm showing you, they can be applied to any relational database. They can be applied to many different kinds of non-relational databases. Okay, because people say that NoSQL database they don't have a schema, which is not true. You can have schema when you're writing, or you can have schema when you're reading. You always have a type of information, how it's structured. The matter, the difference that if it's enforced when you're writing or if it's enforced when you're reading. And many NoSQL database, they require you to enforce the information when you read, right? Not when writing. It's just much work. Okay? But I admit that in many different cases, some NoSQL databases are much better fit for some kinds of problem. Not all of them. I'm just saying that people are realizing that NoSQL databases still have a schema. It's just a schema on read thing, not a schema on write. Okay, so that's the scenarios. And what about my referential technical constraints? No easy answer here. Just drop them and recreate when everything is gone because your application doesn't need the constraints to be working, right? It's just a safety net. To be sure it's not writing the wrong values to the columns. And the same applies to not null constraints. Until you perform all of the steps, you can't apply like not null constraints to your database. And now we're finally to the microservice part of this talk. And Martin Fowler did a very nice job trying to collect some characteristics of microservice architecture. He collected 9 of them in his wiki. But today we only have time. We only have time to discuss this one, the centralized data management principle, which states that there should be only one database per microservice, or each microservice must own its own database. Which also means that if the best practice to start from a monolith, I need to extract my microservice database from the data that was already there. And if I want one database per microservice, but I still have a monolith, it means that for a certain amount of time, or for a long amount of time, first they'll need to read and write from the same set of information, and later, for possibly forever, they'll need to integrate the data between the different databases. Because you think data usually is never isolated. Usually you need to establish correlation between the data. So it doesn't matter if you split information, you always need to integrate the data later because there are some correlations that need to establish to fulfill some business requirements. And I can't help you to decide which piece of information can you extract from your monolith because that's a business modeling problem. So domain-driven design and bounded context help a lot you to decide which piece of information can you extract. But I can help you on how can you integrate the data later after you have split your database from your old monolith. But before I explain to you the 9 different strategies that I was able to collect, I have to explain very briefly some consistency models, and I'm going to explain. I'm going to make a very oversimplistic definition of them. I hope you can forgive me if anybody ever did distributed systems. I'm only going to cover 2 different consistency models, and again, it's an oversimplification of them: strong consistency and eventual consistency. Right? So strong consistency in a distributed environment means that if I have like 5 nodes on my system and I have a variable like I equals to 3 and update that variable to 5, I now equals to 5, all of the nodes in my system, they must agree on the same value before any client connected to any node can read the new value. So I update here, I can until I update all of the nodes to the new information, nobody can read the new value. That's the consistency model that we use to think that we have in database systems, in database transactions. It's usually, I'm saying use it to think, because most of the times we don't have strong consistency when we use database transactions. But that's the model that we learned when we used to database, and that's a convenient way of thinking. But in distributed systems, usually it doesn't scale. That's why we don't adopt strong consistency models in distributed systems, such as microservice architecture. And eventual consistency, in a pure eventual consistency consistent system, if I have like 5 nodes and I equals to 5 in all of them, I could have like multiple updates in different nodes, but we don't cover that scenario because in enterprise systems usually we don't want that. So we're only going to cover strong eventual consistency. Strong eventual consistency means that in a distributed system, I choose one of the nodes to be the canonical source of information, which means that this is the only node in the system in which I'm allowed to perform updates. Okay? So if I have 5 nodes and update I now equals to 7, anybody connected to this node is reading the new value already. But the other nodes might have still the old value. So because the update has not been propagated yet. So maybe this last node was updated first. So now I equals to 7 here. Now I equals to 7. Anybody connected to this node will get the new value. But clients connected to the other 3 nodes will get still the old value, 5. And maybe I already updated I equals to 9 here. So you can have clients connected here and receiving the 9 value. You can have clients connected here receiving the 7 value, and you can still have clients connected here receiving the 5 value. All of the values on the system are correct values, but they might be outdated from different time perspectives, okay? So they can be, everything is correct, but they might be outdated. If you think about that, the world that we live is already of eventual consistency. Because that's the consistency model applied, for example, in bank transactions worldwide. And it's very common for you. Sometimes you go to the ATM, you withdraw some money, like 100 euros. You go to your mobile application. Oh, my mobile application wasn't updated yet because it's a cache information, right? So there is eventual consistency between that. We're just not used to think about it. But if you're thinking about microservice architecture, you need to embrace strong eventual consistency, because that's the consistency model used in enterprise systems. And I'm saying enterprise systems because I'm not covering the other kind of systems. After some research, like 90% of the software developers in the world, they develop enterprise systems. So I believe that we should be helping like this 90% of the people, because I also believe the other 10% of the people, they can figure out the solution for themselves, because they have very, very specific.
Hi there, John Bulger here from version 1. an IT consulting firm that grew from 2 people back in 1996 to over 1,000 people today, with 100 Java developers alone. Core values is something that we take very seriously in version 1 and is ingrained into every decision we make and into our culture. If core values and strong principles is something that interests you, then we would love to hear from you. You can find our website at www.version1.com. Enjoy the rest of the video.
Problems to be solved. So we're solving the problems that like the majority of us are dealing every day. I also have to explain you very briefly the difference between CRUD and SecureOS. And CRUD, most of you already know CRUD. CRUD is a very simple architecture where you use the same model for both read and write operations, which means that we create, read, update, and delete. All of these operations are performed using the same model. So if I create a customer class, I use this class for all the operations, and I also use the same set of tables and columns in the database to perform these read and write operations. It's the most appropriate architecture for like 90% of the cases. It's also the easy one to implement. It's so simple that we have like scaffolding tools to generate most of the code for us. Right? And SecureOS is a very fancy name for something that you've been using for some years. You just didn't know that it had this name. So SecureOS stands for Command Query Responsibility Segregation, and it means that you can have different models for reading and writing operations. What does it mean? So if you have a customer class, you create a customer class and you use an instance of this customer class, you populate the values and use these objects to update or to insert values into the database. But for reading purposes, maybe you need to create another class. You just received the business requirement, you need to create a customer report. But the customer table, the customer class, it has a lot of fields. It has like the address history, the telephone history, the transaction history, or something like that. Yeah? And the business requirement for the report is that the report must contain the ID, the name, and the email of the customer. You don't want to retrieve the whole information from the database into memory just to generate such a simple report. So what do? You create a customer DTO class, which is just a placeholder for information with just these 3 fields. And you create a custom query, you just retrieve these 3 values, you populate these objects, and you perform the report generation in your memory. Congratulations. You just created a SecureOS architecture because you're using the customer class for writing and you're using the customer DTO class for reading. That's a SecureOS architecture. Okay? So many, if not all of us, already done something similar in the past. But after you created your first SecureOS architecture, you just realized that you're not constrained to have a single data store. You can have multiple data stores, and maybe you can create this very interesting architecture, which is a SecureOS architecture with separate data stores. If you ever created a view and issued queries against the view, you created a SecureOS architecture with separate data stores. Or if you created a database materialized view because you needed a report with strong aggregations and it was so expensive to compute on the fly, congratulations, you created a SecureOS architecture with separate data store. And this is architecture that is being applied most frequently in distributed microservices architectures, right? So SecureOS architectures with separate data store, this is the scenario that you need to remember because this is the thing that we're applying in microservice architecture. And how does it work? Well, you create your different classes like customer and customer DTO. Just don't name things like customer DTO 1, customer DTO 2, customer DTO 3, okay? So, but you're writing from the customer class and reading for the other set of tables like a view or database materialized view. And what we're going to learn is which are the strategies that we can use to create this separate read data store. Okay, so remember that. I'm going to get back to it later. But before, last concept before we dig into the integration techniques, event sourcing. Event sourcing is an architecture in which the state of the data is not represented by a column in a table in your database. The stream of the state of the data is a stream of events. The classical example, amount of money in a bank account. So if I have a bank account, you never model how much money you own in your bank account by storing that in that column. What do? You assume that all of the bank accounts start with a zero amount of money, so you create a transaction log. So you add debit and credit operations to the transaction log. So if everybody starts with zero, you just need to apply the multiple add and subtract statements until you reach the current amount of money. You can realize event sourcing is a very good technique for writing. You have no locks on writing, so it's very fast, but it's very slow for reading. Every time you want to know how much money you have in your bank account, you have to start from zero and calculate everything over and over again. It doesn't scale. So that's why event sourcing architectures are usually tied with CQRS architectures. What do? You create another table with another column just to hold a cached version of how much money do you own in your bank account. This separate cached copy is called a CQRS read data store. So you can write your transaction, your debit or credit transaction, the transaction log, and maybe you can update your cached copy asynchronously. So you just write a message on a message buzzer and wait for it to be propagated. That's how event sourcing and CQRS architectures are usually tied. Okay? This is a very, very common architecture. If you need high throughput in writing, and you need to, and you have, if you struggle with the read performance. After all of that, I can tell you that the different integration techniques that I've been able to collect worldwide with different teams of how are they creating these CQRS read data stores in a microservice architecture are these 9. But before, I have to explain to you which is the typical scenario that 90% of the teams have to go through, and I hope that you don't need to go through this path. Is that, well, I'm splitting my monolith, I need to create a microservice. Well, let's decide that I have a monolith. I decide that I want to split the customer information. So I'm creating a customer microservice. I've split the data, so now the customer information is the customer microservice. But since I'm a good architecture, all of my data access to the customer information is performed through DAOs. So all I need to do is my customer microservice, I just create a REST endpoint, and now instead of queuing directly against the database, I just generate an issue like HTTP requests, get the JSON or XML back, and transform that result in a customer object. I solved my integration problems from microservice architecture. That's the number one step that that's the number one mistake that everybody makes. Because when you deploy that in production, it doesn't work. Because it doesn't scale, it's too slow. And then people realize, well, if it's too slow, it's a performance problem. If you have a performance problem, what do? You add cache, obviously, right? So you add cache to your monolith to cache the customer objects, then people have more problems than before. But, well, now it's performing reasonably better, but then realize, oh my god, the internal cache is not fast enough, it's not big enough to hold all of my information. Now I need an external cache. So the cache, create a cache service, they put the customer objects that, and now it's performing reasonably enough. That's the third step. But then you realize, oh my god, my monolith required the customer information in many different points in the system. Right? In the past, I just needed to join information in a SQL statement, join the tables and get the information back. Now I need to join this piece of information in the tables, and I need to join the rest of the customer information from memory. I have to do everything manually through code. It's too much work. I'm not going to do that. And then I realized, why don't I create a CQRS read data store, which is the cached customer copy information directly into the relational database instead of in a cache service. So all of my joins can still be executed. I don't have to change anything at all, and it still keep working. And that's the final architecture that most people, most teams, reach after making these 3 other mistakes. So I hope that you don't make these mistakes and go directly to the final solution, which is usually create a CQRS read data store. I'm not saying that the REST endpoint solution doesn't work. I'm just saying that usually it doesn't perform well enough for you to deliver into production. It only works if you have like very loose requirements for performance or latency or something like that, right? Or else you need a CQRS read data store, and I'm saying that it must be inside the same relational database that to the rest of your system, because enterprise system, they still use SQL for one strong reason. These kind of systems, they have strong reporting requirements. And even in 2017, nobody created a technology as good as SQL for reporting requirements. Okay? You have many other technologies that are much better in other things, but for reporting requirements, we still use SQL.
Hi, my name is George and I'm a Scrum Master at the Equifax R&D Centre here in Dublin. We focus on innovation and collaboration and have a fast-paced, team-driven environment where everyone is a key contributor to high-priority initiatives. We have a very healthy and vibrant agile development community where there is a focus on automation and CI/CD to ensure that the highest standards of quality are maintained. If you would like to learn more about us, please get in touch through our website, which is equifax.com.
And so how do you create this CQRS read data store? You can use shared tables, views, materialized views, triggers, transactional code, ETL, data virtualization, event sourcing, and change data capture. So let's go very quickly for that. I'm over time already, right?
You're fine.
Okay. Don't worry, I'm used to being over time, which is fine. So you can have shared tables, which means that both your monolith and your microservice will be reading and writing from the exact same set of tables. I consider this a hack, but it's the fastest way for you to integrate data. You always have strong consistency, but you have very low cohesion and high coupling, which means that shared tables usually is the perfect excuse for you to not changing anything at all anymore, because you have different teams working on this piece of code, and the monolith team can change the tables because the microservice team is using that. And the microservice team can't change the tables because the monolith team is using that. And this just for 2 endpoints. Imagine if you have 10 microservices accessing the same data, it becomes impossible for you to change anything at all. So it's a perfect excuse. So only do this if you know that, well, next step is changing for a more robust integration technique, because this is not going to work for the long time, for the long run. And another way for you to create your CQRS read data store is through database views, which is the easiest one to implement. It has a large support from DBMS vendors. You might have possible performance issues because on some database systems, a database view is just an alias for a query. And you always have strong consistency because you only write it to one single endpoint in the database. One database must be reachable by the other if you want to have like remote databases, which also means that at least on Oracle, you need a DB link. And I've seen people doing that. I've done it myself in the past too. It works if you don't have like strong performance requirements or latest requirements or something like that. It might work depending on the requirements. It can be updatable, but we don't recommend for you to allow multiple endpoints in your system to update the data, because we strongly suggest you to use a canonical source of information. You can also use database materialized views, which offer better performance than database views. You can have stronger eventual consistency. You can, if you update your materialized view on every commit, you can achieve a strong consistency, but it's a performance killer, so usually people don't do that. If you update your materialized view on demand on a cron trigger, it's eventually consistent. One database must be reached by the other. I know I've done it myself with Oracle's DB Link 2. There was one specific use case where we had a database in an on-premise data center, and we wanted to update a service running at Amazon. So we created a DB link between them. It worked, even with a huge latency. It worked, and it just worked because we only had the requirement because the data just needed to be updated every 30 minutes. And the database materialized view refresh took 10 minutes. So we could reasonably perform the refresh every 30 minutes, and it worked like a charm. It was very easy to implement. Database trigger. You can write every time I update the customer information here, I can write trigger code to update my remote CQRS read data store. I consider it's a strong consistency because you always have transactions, but one database must be reachable by the other, but I consider this to be a hack because it only works for point-to-point integration. It has performance issues if you try to scale that into more endpoints. And what happens is that it is custom code. So whenever I change the customer information, I have to change the remote endpoint too. If I change the remote endpoint, I need to change the trigger. That's why it only works for point-to-point integration, and it leads to cascading chains. Change here, change there, right? It leads to coupling. So it only works for point-to-point, where if I have like 5 endpoints, every time I change one of the endpoints, I have to change here. If I change here the customer information schema, I have to change in 5 different endpoints. It doesn't scale, right? Transactional code is the same kind of solution as triggers, but transactional code you can use store procedures or distributed transactions. Again, you have strong consistency because of the transactions, but it has the same problem as triggers. That's why I consider it is a hack. I can't say that it's a bad practice because I have seen many teams using that for integration purpose, and it works for them. So depending on your business requirements, it can't work for you. I'm just saying that it doesn't scale because it only works for point-to-point integration. As soon as you have more microservice architecture, it really doesn't work because you have such a high coupling that it doesn't perform well. ETL tools, which are the kind of tools like Pentaho, ClickView, Dash Builder. You have lots of available tools. Usually the trigger is like Chrome-based or a button on demand. Since by the time you just generate and extract the data to be stored in the secure readily store, the information is already outdated since it's so it's eventual persistent only. Can aggregate from multiple data sources, and it's a read-only integration, which doesn't mean a bad thing because we don't recommend to be updatable in multiple endpoints anyway. So, and we recommend using ETL tools if you already have an ETL person in your team. If that's a third party, we don't recommend. And if you already have multiple ETL processes running, so create another ETL process is just a quick work task for you. But usually it doesn't scale because you won't have an ETL person in each one of your teams. And if you decide to have more integration points, then probably you want to change to another integration technique, particularly because you want to apply monitoring to these integrations. You need to know if everything is integrated correctly, right? This one is one of my favorites, data virtualization. What I want to show to you here is that you have your physical database, and I expect you to read, okay? You create virtual databases in the middle layer, and you have your client applications accessing the database. What is a virtual database? Well, it's a virtual database, which means that you can play, I've only seen 3 different teams working with that. None of them bought a data virtualization solution just for microservices, but since they were already using data virtualization, it was very easy for them to adopt microservices because they didn't need to change the physical database. So what did they do? Because one of the problems with splitting the data is that, well, I decided to split this information. I did it wrong. So it took me like weeks to split it apart, and it's gonna take me weeks to get it back later. It's too much trouble for achieving nothing. So what did they do? Since they're using virtual database, they can keep the monolith reading and writing from the physical tables, and then just play with the data. Well, let's create a microservice with this virtual database. If it worked, awesome, you can split the data physically. But if it didn't work, you just discard the virtual database and start from scratch because nothing is lost. Okay, so that's why it was very interesting. I have seen only 2 teams in the past, but this weekend I talked to a person in Philadelphia, and they used virtual database virtualization for creating their microservice architecture, and they were very happy because they said that they made many mistakes in the beginning, but they were all safe mistakes because everything was virtualized. They just discarded the virtual databases and started over. Event sourcing, as I described before, it eases auditing because you always can replay the transactions to see the amount of money. In the example, it's always eventual persistent because you need a message broker to be propagating the message into your system. And I'm a bit concerned that many people are advocating event sourcing as the source, as the solution for all of the integration problems that you might have in distributed systems. Because people say, oh, since you're using messaging, you have low coupling and everything else. I have to tell you that it's very hard to do sourcing properly. I've seen many teams fail in that. So usually you just have a distributed mass, because you don't realize that the coupling in your system when you're using event sourcing, the coupling is not in the code anymore. If you have a monolith, you want to refactor something, you have your IDE. If you have a distributed system, the point of coupling between your systems are the messages. So in every message, it has a type and a semantics. So every time you change the type or the semantics of a message, or you add a new message to your system, you have cascading changes. That's the coupling of your system. So if I can have my system, I have 20 different endpoints. I add a new message to my system. I have to change all of my 20 different endpoints because they need to be prepared to receive this new message. Or if I change the type of a message, again, I just propagated everything. So it's very easy to do it wrong. I only suggest you to do event sourcing if you have a very mature business model, you know exactly the kinds of messages your system is going to have, and they're not going to change much with the time. Because if you're still learning how the things work, never do that, because it will be a mess to maintain later. Okay? And chain data capture. This one is one of my favorites too. It's an integration technique where when you don't want to change anything at your application at all. So CDC tools, chain data capture, they plug directly into the database system. They read directly the information from the database transaction log. So what do? They connect, and for every insert, update, delete, or alter table that is issued against the database, it creates a message and propagate that through a message bus. Some people call it like poor man's event sourcing, because you're generating events from your database. But since it's low-level events, insert, create, insert, update, delete, and alter table, this kind of events won't change over time. Okay, so it's very easy to maintain. You don't have the richness of domain events, but you also don't have the coupling problems that might arise from that. And it's highly scalable too. And I want to show you a very cool demo of these tools. Anybody ever used Oracle Golden Gate? No? Some people tell me that it costs you like 2 kidneys because of their expensive solution. But Golden Gate can be used for many different scenarios, but Golden Gate also has a CDC tool. It allows you to replicate data remotely, just plug directly into the database and start replicating your data. And I want to show you a very quick demo of an open source project tool that performs CDC tool. It's Debezium.io. How do you call Debezium? Because it's DB, database, and they added a Debezium because they wanted that to sound like a chemical analysis.
Equifax is a great place to work for, especially to develop your skill set as a developer. The company culture and the office atmosphere and the location are all perfect. A lot of our projects actually focus on big data and the cloud, so we use a lot of cutting edge technologies in our projects. So you'd see things like Java 9, Angular 2, AWS, Docker, and recently the ELK stack. You're constantly working on projects and products that are actively used every day, so that you know that your work actually means something. So if you'd like to learn more, get in touch and log on to equifax.com.
Okay, so Debezium, that's how they coined the name. I was expecting a fancier answer, but that was the answer.
They probably paid a lot of money to come up with that, you know.
Yeah. Yeah, and it was like, nobody had, how to say, registered the name before too.
Okay.
So that was some of the reasons. So, I want to show a very quick demo of Debezium running. Here I have in my notebook, I have a Zookeeper instance running, just because it's a distributed system and I need to store global state somewhere. And Zookeeper is a requirement for Kafka. How many of you have heard about Kafka? Okay, some. Kafka is a distributed message bus. It was open sourced by LinkedIn. In fact, it's the favorite one for new projects these days because it's highly scalable. In some conditions, it can be, it is persistent, and in some conditions, and it can be an ordered queue. So all of the clients, they always receive the messages on the exact same order, which is a very important thing if you're dealing with event sourcing, because depending on the type of your data, you expect clients to process the messages in the exact same order, because you don't want to like add, multiply, or something in the different order, okay? Or you don't want like the latest updated to be shadowed by the node update. So that's how it works. And here I have a MySQL server running. Here I have a MySQL clients, Debezium running on here. Here I have a Kafka watcher, which is just an application that watches the message that is passing through Kafka. What we do? Here in my MySQL database, I have some information. I have these and these. You can see the ID 1004. It's N Kresma. So I'm going to update that row. And update the name to N Mahi. So now the ID 1004 is N Mahi, and let's see what got propagated by Debezium on the Kafka bus. Debezium generated this message, but it's very hard to see. So I want to copy and format the message for you. So what happened here? Debezium generated the message. If you see here on the top of the message, Debezium always propagates the database schema as it was before and after the operation. So, but in this case, nothing changed because it was just an update statement. But the nice piece of information is this one. Debezium propagates for you the payload. So the payload before the operation was this one with the first name N, and the payload after the operation was this one with the first name N Mahi. So you can see, and here we have some internal information, and I'm saying that the operation is an update statement. You can see that you can easily create your own CQRS with the store with the information that Debezium has propagated. You don't have to store all of the fields in your grid data store. You just store the fields that are important to your microservice, okay? And I have other examples too, which I'll skip. But many people ask me, what happens if Debezium goes down and people keep writing to the database? Debezium stores the point in the log in which it is processing in the Zookeeper instance. So if Debezium goes down and it comes back again, it just knows where it stopped and starts to broadcast the events from the point it stopped. So you never lose a message if you're using Debezium. And Debezium, as I said, it's an open source project available for free. It's sponsored by Red Hat, and currently it supports MySQL, PostgreSQL, MongoDB. You have Oracle support, but it's not considered final. But it's going to be soon final. But again, I'm not making any promises, right? And SQL Server probably is going to be the next project to be supported. But again, you don't have to trust what I'm saying, right? I might be lying. And that's what I wanted to share with you with this talk. All of this information is available on the book and of course on the website too, developers.redhat.com. I would love your feedback for any integration technique, different approaches or problems that you had. The best way to reach out to me is with my Twitter handle @Yanaga. Email works too, but usually I take a long time to reply, so it's easier on Twitter. And again, thank you very much for being an awesome audience, and I'm very happy to be here at the Dublin Juke. As I said before, the most excited jug that I've ever been. It's thanks to Barry. You know, said that all. Right?
We're going to stop and have some pizza now, but before we do that, does anybody have any questions that they'd like to ask Yanaga? We'll take 3. Baron.
Okay, so you have those steps there where you would read in and call and just keep reading from the old one and write to both. And then, so will they, each of those steps, different deployments of your service, for example?
Yes, each one, 1, 2, 3, 5, 6, each one a different release of your software into production. And you might be thinking, oh my God, it's going to take months for me to apply database migration, right? It is if you have like 1 release per week, but most of the teams using that, they were doing multiple deployments per day. So some teams like to perform all of these steps, they took like 1 hour because they deployed, monitoring, everything's okay, data is okay, next release. And that's how they did. Okay, but if you take if you have 6 steps and you release only once a month, yeah, it's gonna be hard.
And Remy, did you have a question there?
But just a remark, the Division, is that the same as DynamoDB's, Amazon's DynamoDB's?
No, DynamoDB is a column storage NoSQL database, and Division is just a CDC2.
But on DynamoDB, you can basically let all changes, the reads, the writes, the updates, all get published to SQL topics, and you basically can process them and do something with it.
Yeah, well, I wasn't aware of this.
So
this
DynamoDB has that built-in, obviously, already.
Yeah, but the advantage of Division is that it's an open source project. It works anywhere, and not specifically on Amazon. I will discuss this thing on the next talk, like open source and locking, this kind of stuff. But it's, I didn't know. Well, thank you. It's very nice to be aware of new things happening.
More question?
Yeah, I wonder what's the other advantage of keeping databases virtualized or testing microservices? Because if I would like to test my new microservices that I extract from the monolith, it could be quite easy if I just put my local MySQL or Postgres database without struggling with the virtualizations. Or maybe I'm missing something.
Okay, because if you install another, like MySQL server, and your microservice is accessing that, you still need to move the data from one point to the other, right? And then after you migrate the data, you need a way to update the two endpoints.
Okay, so I test migration from the...
Yeah, so here you can, and it's a lot of work. So if you use Division, if you use database virtualization, you don't need to do all this, you just create a virtual database, because everybody's reading from the same physical database. So it's a safer step, because you can see if it's going to work before performing the actual migration.
Yeah, you're right. Okay, thanks.
Cool. Okay. Well, obviously you ask Yanaga some questions at the break if you'd like to do that. So we have some pizzas, and they're outside. So you can go out there, grab your pizzas, come back in, they'll give people a chance to get at it. But before we do that, I would just like to say, first of all, a big thank you. Well, number one, to you guys for coming along, but also number two, to our partners in Dublin Java User Group. Because without those guys, we wouldn't be having pizza, and we wouldn't be having beers, and we wouldn't be bringing over amazing speakers as well, that are coming independently into Ireland. And also, thank you very much to Red Hat, because without their support, you wouldn't be here.
Yeah.
So thank you very much to Red Hat as well. So, pizza! Well, what did you think of that? I really hope that you enjoyed it. Just remember, if you want to become a member of the Dublin Java User Group, all it costs is €75. €75 gets you the entry for 10 events. It doesn't have to be the next 10 events. It could be 10 events over 3 years, but it lasts for 10 events. It's superb value to see all these guys in Dublin